My microphone is on. Look at all these lovely people. Thank you for coming. Busy SIGGRAPH, lots of options. I'm honored that you're here. And I'd like to convey that this is the craziest talk I've ever done. It's going to have 8 live demos with brand new technology. What could possibly go wrong? So we're going to start this off with a bang. What's Cinemachine? Somebody give me an answer. Someone yell it out. Ooh, I want to give you the prize for that, but you're so far off base. Someone else, go for it. There's a prize. I'm not even kidding. Okay, that's it. Look at this. You look like you're the right size too. An official limited edition Cinemachine, super nice hoodie. I laid it next to my suitcase. My cat fell asleep on it, so there might be some fur on it. So, cameras in the real world, look at all that stuff that's going on. Look at all the relationships between the camera and the subject. You got a guy looking through the lens. You got a guy pulling focus. There's all this stuff happening. There's this rich ecosystem of information between that stuff and what's being filmed. And in CG, it's this. They don't know anything about each other. And it's been my crusade for getting on a while now to give cameras the understanding of what's happening. So as an artist, cinematic maker, someone making video games, you tell the camera what you want it to do. And if something changes, the camera still figure it out. And that's the spirit of what Cinemachine does. And I implore you to try it for those who haven't. Let's do a quick poll. Who has messed around with Cinemachine or is using it? Okay, good. Thank you. Awesome, my people. The rest of you, you should be ashamed of yourselves. This is how you get it. It's really easy. Unity's going into packages now. Cinemachine's a package. Depending on what template you load, it's there. And if it's not, you go Window, Package Manager, hit Cinemachine. This is how we're delivering like HDRP rendering and ads and all the other goodies. The reason being, Unity can actually get smaller. We can iterate on it faster, and all the modules are external. It's a great idea. So that's what Cinemachine lives. And if you want to be on the bleeding edge, and this is not just for the Cinemachine stuff, you can go to your packages folder, and there's a little file there called the manifest.json. Don't ask me why it's a Firefox logo on that. And you add this. You can search this online, but basically what you're saying is, give me the stuff hot off the press, warts and all. And what's cool about this is by modifying this, and this isn't, again, just with the camera stuff, you're telling Unity to look at the stuff that we're directly working on. So we'll do a preview drop and you can get it. And we will turn things sometimes around daily. Someone will say, I want a feature. We're like, get it, it's in preview, boom, you got it. Also, and I say this at every talk because more people need to know it, we have all these example projects, tons of them. You go to the window and you go import example asset package, and you're gonna learn more about how to do this than I can in a long time up here. Go through each of these scenes, make yourself a nice cup of coffee and go through them. They're fun, you're gonna see the power. There's so much stuff in here. It's so much bigger than a lot of people realize. Look at all those fun scenes. And for those who are super bleeding edge, 3 days ago, we just dropped version 2.3.5. And I don't expect you to memorize this, but you can see that we've been busy. We've added new features, we fixed some bugs. Always moving on. This is how many demos I'm gonna show you in however much time we got left, so I'm gonna go fast. So Sherman is a short film that our group did. I'm part of the innovation group. And we did it after finishing the Disney television animation Baymax Dreams, which we won an Emmy for, which is amazing. So our group did this, kind of back burner, like in between things. And it's all in Unity, and hopefully the volume works. So many people ask, did he die at the end? So we have to make a sequel. Now, I'm not just here to show this video. We're gonna give you that entire project. The fur, the filmic motion blur. At the end, take a picture because there's a link in there and you can download the entire thing. And something I wanna mention is we worked on a new motion blur. We worked on new fur. We worked on all sorts of new stuff for this. But the motion blur, check that out. That is not video game motion blur. It respects the fur, it respects depth of field. It's amazing. And it's included in this project. It's slow, it's not video game motion blur, but it's, I mean, like, look at that. It's close to pre-rendered film grade motion blur in a game engine. So take it away, that's for free. That's jumping way ahead. Okay. So what is Cinemachine? I'm gonna give you a really quick, I've done this demo before, but I just want everybody to get it. What are procedural cameras? So here's timeline, you guys know that. These are procedural camera clips. There's no camera animation in this scene. This clip is this camera, and we're saying, look at this dude's head. And put it here on the screen, but you can say wherever on the screen. And what we do is we actually flatten all that 3D space and we look through the lens just like a cameraman and we procedurally compose on that guy. And you can see when I move, there's like a little bit of dampening. We can emulate handheld movement, emulate the mass of a camera. We've never seen a camera instantly start or stop. I mean, you can spend hours going into that stuff. We spent a lot of time there. But you can see these dudes are moving and the camera is automatically framing it. And that's one idea. And that's fast to work because you know what happens is you can do that and say, well, I want to move the camera. You just grab the camera and move the camera. And you still get that shot. So you see here we're going to a cut. We're going to do a cut to this new clip as they walk by. And this next one is a procedural follow camera. And what that is that's a camera that's, you're telling it how to follow something. So we're saying, follow these dudes and follow them this far away. I can put a little bit of handheld noise on it, get a whole noise system. I'll do strong. And we're emulating, it's maybe a little high frequency, we'll just turn that down. We're emulating like a guy with a Steadicam following these guys. And if they move, or your director says have them move faster or slower, cameras have figured it out. You've already told them. So then it gets interesting because, well, this is all virtual. There's no actual animation here. So you can start to do some pretty bonkers stuff. So see this cut here. I'm gonna just put them a little closer together. This is like terrible cinematography. They walk by, then we cut to this follow camera. Horrible. What do you think happens if I do this? See that little triangle-y guy there? Because it's all in timeline, because everything in timeline blends, because we've set all of the math to blend, we blend from this tripod shot straight into the follow shot. And now you're working with ideas, and you can mix these around, and you can say, no, start with this one, end with that one. You know, that blend needs to start sooner. And you start thinking about these things as shot ideas and concepts. Let's go a little sooner. You can see the camera blend around here? You can actually see it blending from this guy to this guy. And when you think like a cinematographer, and I'm sure many of you do, you think about what's needed for each shot, like how you want it to look, what the colors are. So we put the post-processing on each of these clips. That's down here. It's like resolve like color grading. And for giggles, I'm gonna do this. We've now got black and white mode. We've turned it into a French noir film. So not only does this live on that shot, but this blends. So you guys know what's gonna happen next. We go from color, we do this move, and we blend into black and white. And you can work so fast this way because it's just ideas on your shot, ideas on your shot, ideas on your shot. And then someone can say, you know what, make everybody walk faster. I'm totally breaking this, but I'm just holding shift and changing the durations on this. And everyone's walking faster, a little bit faster. And it also works because the cameras have that relationship with the subject. You don't have to do cameras last. You can do them earlier on, change your mind, go crazy on layout. You know, it's just a really fast way of working. So we're gonna go straight into the deep end. And this is a new feature called Reactor. And I started doing this stuff. I used to work at Electronic Arts and I did the cameras for the Need for Speed series, the driving games. And in a driving game, the physics of the vehicle are really so much also the physics of the camera. The elasticity when you hit the brakes, when you accelerate, and feeling the corners. And there's this dance between the camera and the subject. And you don't want to code all that stuff because, like, well, what if, you know, we hook the RPM up to the noise, so as the engine revs, the camera shakes a little bit. And tons of other ideas like that. So I got these assets at the asset store. You know, it's just, don't look at the graphics. But this is a driving game. And I'm gonna show you car boring camera, which is right here. And this is a terrible camera. And we will see what a terrible camera looks like. You can guess. There's like very rigid. There's no dynamics. Let's turn off this canvas stuff. Okay. Car accelerates. Camera's right there. Car brakes. This is terrible camera. We've seen some games ship not far from this. So, I mean, it's a Cinemachine, so you can do all sorts of different things. Like, why don't we, I don't know, put a little damping in Z. So when he accelerates away, when he brakes, you know, you can feel it a little bit. Maybe we put a little yaw damping in. So now we've decoupled the camera from the yaw of the car. But this is still super ghetto. And you can get kind of close with this stuff, but really none of the Cinemachine modules were specifically designed for driving cameras because they're complicated and you can have a lot of things from the game coming into talking to the camera system. So let's do something crazy like this. What if we took visual scripting and cameras and put them together? This is our new visual scripting system. It's super powerful. We custom built these nodes, and these are remap nodes, and they take anything to anything range in, and you can remap it to anything out. So for example, FOV, we have the speed coming in, the speed between 0 and 28 meters a second. There's an output range between 0 and 20 change of the FOV in degrees, and here's the little curve that I want for that. And you start to layer them. On Need for Speed, I had 47 channels from car information coming into driving the camera. And we didn't get too crazy because we just did this many, but look what it feels like. I switched from car boring camera. Those of you who use Cinemachine know, you just turn off a camera and turn on the other one and it all just works. Now this, I can feel the gear changes and it pulls ahead. And as I go faster, that FOV widens up. Very common video game trick. And then I've got some way too much noise, but just to show when you start going fast, the noise picks up. And I'm crashing everywhere. And look at this. I've decoupled the slip. So as soon as the tires slip, we burn out, we let the car move on the screen. You see that? So as soon as you start to skid, you've got this whole other driving mechanic that's happening, camera relationship. And at any point you can be like, well, let's just do, I don't know, 40 on the FOV. It's up here. 50, this is just gonna be silly. But you can see you're doing it while the game's running. I've since crashed into a tree. And now as soon as we speed up, the FOV is going to get wider and wider and wider, and we're going to add 50 degrees of lens to that. I mean, it's ridiculous. But look how fast this is. And think of an environment where you can take anything that's happening in your game, pipe it through a remapper, and plug it into anything to do with your camera. Super powerful. That's called Reactor. And it's coming later this year. Okay, this is fun. We chat with film studios often, some very household name animation studios, and I can't say who, but we were having this conversation the other day, and they're like, yeah, we get Cinemachine, it's cool, procedural, yeah, but it's kind of mechanical, and we wish you could just emulate what happens in real life when you film these things. And in real life, we've got these things called Technocranes, and there's multiple operators. So one person will push and another person will do something, and they all make like little mistakes and they all compensate, and all gives this little mojo and this camera movement awesomeness to it. So why don't you guys have a Technocrane? And we thought about it. And then we said, why don't we have a Technocrane? But let's go crazy. Let's hook it up to our new input system. Let's hook it up with our new animation rigging system, which all this has. And let's make one that you can forward animate, you can keyframe it. You can drive it through whatever. Look at this cool thing. Or you can use procedural components in any kind of hybrid. And I'm going to attempt to show you that. So we wired this thing up. It went super quickly. And we just said different knobs control different things. You can do it in an absolute way, or you can do it in like a motor way. This one does look up and down. Oh, there's a car there. There's people who master this stuff at driving it. I'm not one of those people. But now you can keyframe, and you've got this. I mean, we're just going to give this thing away. But we've now got this Steadicam rig. We've got pedestal and all the goodies. And this is going to be something that we'll put in Package Manager and give away. But here's where it gets cool. This is all me forward animating it with this thing, right? I don't even know where the car is going. Somewhere around here. Okay, so oh, here it is. Yeah. Okay. Don't record this. This is terrible. Okay, so input device, Technocrane, super cool. What if? Let's do something like this. Let's take this Technocrane and let's put a different head on it. I'm going to turn this head off. Now, this head is a Cinemachine composer. And what composer does is it's a procedural composition, and it just does rotations. And if I select this thing, you can see I'm looking at the grille of the car. So now look what happens. I hit play, and no matter how drunken I am on this thing, the head's always looking at the car. And this is a really interesting space, because what we're now doing is we're mixing direct input, but with elements of procedural real-time stuff, so you can get stuff that's way smoother than, you can be like, well, I don't want to look there on the car. Why don't we look a little bit further forward? And this is all done, with the composer, of course, and you can put this up here, composer shot however you want. I'm going to turn the damping down so it stays pinned. And now whatever you do, that part of the car is pinned to that part of the screen. And I'm not going to try to show you the sexiest camera move right now, but you get where this is going. For the people who are in the film industry and they use the Russian arms on cars and they drive around. Imagine the ability to have that, but to not have to control exactly the rotation. If you want to, great, get all that human motion in there. But if you want to, do procedural composition, then you got that too. So that's Technocrane. Is everyone having fun? Is this okay? Okay, good. It's very quiet. I'm like, they're all on their phones, half asleep. Okay. Okay, free look 2. This is a quick one for people doing games. Third-person action-adventure games, the cameras, it's really hard. Think of like The Last of Us or Red Dead Redemption. Really hard. And you need to change these cameras based on, if they're in a small space, in a big space, maybe as more enemies come up, if you're firing weapons. For those familiar with Cinemachine, we have a free look system. It's now called free look 1 because here's free look 2. And this is a really quick demo, but what I want to show you is that we've been working on third-person orbit camera systems that are really good for targeting and for shooting. That was one of the bits of criticism that we had from our previous one, is that the targeting wasn't super bang on. And what we have on this one is this new method where, I'll show you the cameras right here. It's a framing transposer. For those who use that, that's how it adjusts the body. I can set all the damping to be 0. And it's just hard pinned to the guy, where we can turn the damping up a little bit. And the camera has a little bit of a weight to it. That's too much. But we're using the POV, the aimer, on the reticule, so it's bang on accurate. And it's, this is a small thing. It's coming out in the new Cinemachine, but we've got a new free look. And for those people doing third-person action-adventure stuff, this damping's way too high. It's definitely worth taking a look. Our forums are very active, the Cinemachine forums on Unity, and we've got some posts that talk about this. So that's a cool new third-person action-adventure setup. Okay, this one is the craziest thing we've done in a while. So crazy, we don't even have it. We're calling it the Mojo Extractor. It is one of the proudest things to bubble out of the Cinemachine distillery. And it's going to take me a second to explain it to you, so bear with me. When people do virtual production and they have cameras and they record the cameras, you get all that juicy motion, right? All that lovely texture. So, and that's great. That's why we do it. We want all that motion. The problem is, it's not really real time, because if something changes, you got to shoot it again. You got to capture it again. And we were thinking, is that the way that the world has to be? So here's a clip. This is from Adam 2. This is literally Neil Blomkamp, the director, holding the virtual camera. And he filmed this sequence. And you can see, his footsteps and all the mojo. Now, let's say you want to change your mind on this shot. And you're like, come at it from the side, or put them further away. You can go into the curves and edit all this stuff. And animators that are out there know, yeah, you just put a node on top and you start animating this. But you got a keyframe on every frame. It's like pretty yucky, right? Like, you just can't take a motion capture shot and then rotate it 90 degrees to the right or something and have it work. That's just not how it works. You got to capture it again. So what we said is, screw that. We made this thing called the Mojo Extractor. And the way it works, there's a little bit of magic in here, is we look at the way that the camera's moving. We look at all that motion, rotation, translation, and we throw it into a file. And then we can create a virtual camera, and we apply the Mojo to it. But now that it's a virtual camera, you can do anything with it. So you see how the vignette came on just a little bit, just to let you know. That's the original shot, Neil Blomkamp animation. This is the Mojo extracted, but now it's a virtual camera. You can say, well, let's change the composition on this shot. And you've got all the Mojo. You've extracted all of that animation information. We've brought it into the Cinemachine world. And you can do whatever you want to this. And you can say, well, let's go further back. Let's go to the side. You still have that mojo. And you can push it pretty far before it breaks. And I know this is a bit of a weird idea, so I want to make sure everybody gets it. When you motion capture cameras, those keyframes, you can't really manipulate them that much. You can't say, well, hey, let's just take this shot and compose it this way, because you've got a sea of keyframe data. But by doing a Mojo extraction on it, and putting all this information into the camera and keeping it in the Cinemachine space, you now can do a virtual camera shot, motion capture it, and then your director can say, no, man, go further away. And I want to have a center punch composition. And you can change a shot and you still get that animation. And then even crazier, because this is all relative, you can say, well, make him walk faster. And all of this camera information is relative to the character. So if I make him walk faster, the mojo still works because it's relative to him. So your director can change animation speeds and change things around and it's still gonna work. Yeah, he stops and the mojo continues on, but it's all relative to the character. Or you can say, no, don't look at him. Look at that other guy in the scene, this wasp guy. So I'm gonna take this camera and we're gonna look at him. Well, let's pick a better bow on him. Let's look at his pelvis. Now we've taken the mojo from the one shot and we applied it and we're recomposing on a totally different thing. So I don't know if everyone being quiet is like, that's cool, or it's like, I don't get it. But we think it's gonna change how people do virtual production. Hopefully a little bit. So you don't always have to do cameras last, right? You don't have to record all your cameras at the end. You can actually do some stuff earlier on. How are we doing for time? How much time have we got? Oh yeah, 8 minutes. Sweet. Dots. Who knows what DOTS is in the Unity world? Okay, one person. DOTS stands for Data-Oriented Tech Stack. And without getting into a discussion about the diversion of programming languages and how memory works on a computer, because I actually can't go very far into it, they've diverged. And DOTS is a new programming language that makes things, the simple way of saying is it makes things go really fast. It gives you hyper-optimized environments where you can do completely bananas things, and I'm gonna show you that. This is a programmer art scene with a shark and a whole bunch of fish. And the fish in the scene, there's 5,000 fish in the scene. Every fish has a camera that follows it. Soon, when I hit play. Every camera that follows it is doing a raycast. Raycasts are expensive. And every camera that's following every fish has got a damping method. So as the fish moves, the camera goes. That's expensive. Here is 5,000 fish, 5,000 cameras. I'll go back to scene mode. And each of those orange arrows is a camera that's actually figuring out a shot. We could switch to any of them. They all avoid the shark. And you'd never, ever do this in real life because why would you need a camera following every fish? But we're running at 200 frames a second. Previous Cinemachine at about 30 cameras would crap out. So this is where it gets crazy. DOTS is going to change how people use 3D. It's this amazing advantage that we have over our competition. And it's going to allow people to do stuff on like mobile devices that is insane. Numbers of things that you couldn't even dream of before. This is 50,000. 50,000 ray-traced, dynamic, active cameras. Now we're running at 50 frames a second on my laptop. Like, this is completely bananas. And you're thinking, why would I ever need 50,000? Well, this is a new laptop. I swear to you, I've not tried this yet. 500,000. Let's see what happens. 500,000 active raycast dampened cameras. Like, what? I'm going to get to an example why you would actually need this, sort of. It almost makes all this make sense. My fans are kicking on right now. Of course they are. This is silly. We're doing 500,000. Let's see what we get. What do you think we're going to get? 12? It's pretty optimistic. 4 frames a second. Look at this as a ball. 500,000. And so it's not just the cameras. We're also doing the fish, the shark. Like, this is crazy. Okay, so why? So we've been working on this for a little while. I gotta speak over it because it's a little bit hard to understand. I'm fascinated with the problem of how you film something when you don't know what's gonna happen next. Procedural cinematography. How do you make a movie out of something when you don't know what's gonna happen? Super daunting problem. We sort of tackled it here. This is some technology we have called Cinecast. If you're super into this, you can come bug me after and we can talk about potentially sharing some of it with you, but we're still working on it. Programmer art. 4 dudes. They're running around. In the world, there's 2 layers of cameras. The red ones on the walls, just cameras stuck to the walls. 4 virtual cameramen following each player. And they're the red guys which follow these 4 dudes around. The blue lines are raycasts. What can I see? Can I see player 1? Can I see player 2? Each camera is doing a raycast to see if it can see something in the scene. If it can see it, we put it to the right. Then we do a quality score, an evaluation. How good is my shot? Good is a conversation we need to have separately from this. We're doing a very basic good. How big is it on screen? Which way is it pointing? Those kinds of things. We rank how good each of those shots are for each of the cameras. So there's that many active cameras right now, this little crappy test scene. Then we say, what's interesting? Well, these guys are just running around, so their interest isn't very much. But in a game, interest can be anything you want. And this is where it gets sexy. What's the best camera that shows the most interesting thing? And then when we cut, don't cut across the director line. Don't do a jump cut. Preserve the guy's screen space. We've got about 8 cinematography rules which we've trained the system. So these dudes run around, the raycasts happen, and then we will make an edit out of this. And we did it for a video game. We did it for a game called GTFO. It's still in development. And that's not why it's still in development. People laughing. And watch, it comes up here. And it's completely automatic. So you can see these guys running around. The camera is getting different levels of how cool their shots are. The top right is what's interesting. The door opens. When we cut to these guys, the door opens. We cut to a wider shot because that's more interesting. Enemies show up. We cut across. We don't cut across the director line. We don't do jump cuts. We don't do same cuts. And you can play this game and a movie pours out and nobody's doing anything. And I see a future of esports broadcasts because right now they're pretty hard to watch. I mean, it's great to see through the player camera, but imagine making a movie out of something in real time. And that's what Cinecast is all about. And we got 1 minute left. I want you guys to see. Yes, we're hiring. I'm literally hiring. Come work with me. I need another person. Our team's growing. I'm desperately trying to find some people. Take a picture of this. The Sherman, they're the blogs. There's where you get the entire project, download it. Cinemachine, Cinecast, cinematic stuff. And then if you want to stay in touch with me on Twitter, I ramble on about this kind of stuff and we'll answer any questions you have. We got a minute to take questions, so if you got one, please fire away. Yes, hi.
Can you explain a little bit about that dot running language? Why it's so fast? Is that you accelerated or it's just a better CPU size?
It's hyper optimized in terms of memory management. And what we're able to do is multiple operations in the same cycle as you previously just did one. We've got a really good blog post about it. Come talk to me after. It has all the information. It's a game changer. And that's me without a Unity hat. This stuff's crazy. It's going to change everything. Any other questions? Hi.
Do you have an easy way to export your virtual cameras to USB?
Oh, good question. So we support FBX right now. We have a USD in and out. The camera situation is, this is a way of me saying sort of. It's not a yes. Right now, our main camera that we get out, we do it either through Alembic or we do it through FBX. USB supports both of those, but we don't have a direct camera out in that sense. We sort of configure that per project. So come out and chat with me after. I can show you what we've got. That's an area that's still in development because, well, USD is kind of new. That's not really new, but everyone's jumping on it now and they're trying to figure out the best ways to handle these things. Hi.
Do you have any techniques to work together on a team in the same setup, like one scene?
Mm-hmm.
I assume there was more than one person on
Sherman, absolutely. So that was cut up. The whole project is built around multi-users through nested timeline and use of prefabs. It's covered in the blog, and there's a video that goes into it too. It's a great question, and we've set that up. You can take it away, and we show you one of the best practices of doing it. There's a few ways to do it, but this is the way that we like it the most, and it's right in the project. Anybody else? Hi.
Excuse my ignorance here, but can you bring the Alembic or anything like that, or the animation from animation software, say, whatever, something that's pre-baked, work on your cameras and put the cameras back?
Yeah. Yeah, so the question is, can you bring something in from the DCC, Maya, whatever, and the whole camera round trip? That's exactly what we did on Sherman. That's what we did on the Disney project. We block cameras into Maya, we bring them in. We ended up doing them all in Unity at the end, but we would export them back so the animators would have a reference, but we didn't bring them back in because the director would be like, change a shot here, move an edit there. And we were doing like edit changes to the last day, which is somewhere between terrifying and amazing, depending if you're a producer on or off the project. That's it? Okay, thank you. Thank you so much for coming.